This is going to serve as a little bit of a review. Suppose records show for a certain group of U.S. adults, 26% are paying on student loans. Call that event A. 51% are earning at least $60,000 per year. Call that event B. And 13% meet both of those conditions, both that they are paying on student loans and earning at least $60,000 per year. Select one of these U.S. adults at random, and we want to see if these are independent events. So, first off, we need, if they are independent, that the probability of the intersection would be the product of the individual probabilities. And vice versa, if we have this number as well, and we do this multiplication, and it does equal this, then we know they're independent events. If, on the other hand, we have these two numbers and this third number, we do this multiplication, and it doesn't equal this, then we do not have independent events. So, let's take a look at that screen share again. The 13% is our probability of A intersect B. So we want to see if 13% equals the product of 26% times the 51%. And while it is close, it is not exactly the same. Therefore, A and B are not independent events. What that means is that for the remaining parts of the question, we are not going to be able to use multiplication. What's the probability the person is paying on student loans or earns at least $60,000 per year? Give you a moment to reread that. One option is to use the general addition rule. That 13% was what we had in the intersection. Or if you did a Venn diagram, then besides that 13% in the middle, we would have 26 minus 13, where they are in the group that is paying on student loans but not making at least $60,000 per year. And on the other hand, we would have 38% in the group that is making at least $60,000 a year, but not paying on student loans. This is what would come up in a Venn diagram approach. You've disjointified the two overlapping circles into three mutually exclusive events, and we get the same amounts. No multiplication in there because A and B were not independent. So the probability a person is not paying on student loans and earns less than $60,000 per year, that's the part right here, 13%. Oh, sorry, they are neither. They're not paying on loans, but they also earn less than $60,000. So that's 64%. We're going to take that away from 100% and get 36%. No multiplication involved. Okay, that's all I've got for now. Hope this helps.